My name's Peter McLeod. I'm the moderator this morning. Thank you very much for coming along to what I think is going to be a fascinating session. Everything's on that slide there. You don't need me to read it out. My other four esteemed guests sitting here to my right, I'm going to ask them to introduce themselves. We can go down the line, starting with you, please, Harry.
Hello, my name's Harry Carmazin. I'm Head of Product Development for the low power products at Intelligent Energy. What that means is we make fuel cells and fuel cell systems. There's big ones and there's little ones. I look after the smaller ones, perhaps powers up to 10 kilowatts. The smaller fuel cells cover applications up to sort of the 10 kilowatt type region. But one of the things with intelligent energy fuel cells is they're small and compact and power dense, which makes them really interesting for the world of materials handling. And one of the things we were looking at a number of years ago, which is we're now working on very actively now, of course, is fuel cells for materials handling applications in low-level order pickers where the battery boxes are quite small and narrow, and that makes it a tight application. And because we were working on that, this application with BMW, where there is an AGV which has got very tight space, was really very interesting to us because we had something small enough to meet that application. And as the other speakers explain what's been going on, you'll learn how that size capability allowed us to provide traction power in what is a small vehicle.
I'm going to Ulf Jørgensen now. Ulf?
Hi, yeah, thank you very much. My name is Ulf. I'm the CEO of H2 Core Systems. We are concentrating on building up the hydrogen infrastructure, the missing piece of the puzzle to get rid of the headache problem. Concentrating on building up fluid systems, integrating small electrolyzers, medium and big electrolyzers, integrating those into systems, combine them with fuel cells, with storage, compression and dispensing systems, so everything that's needed to self-supply hydrogen on site. That's what we are doing.
Thank you very much. Working our way down the line, please introduce yourself. Thank you.
Hello, my name is Stefan from FES in Germany located, and we are a collaboration partner from Intelligent Energy, and we use their IE lift module at our common project with BMW in Leipzig, where we just put in where we did the system integration of the fuel cell in the AGVs.
Thank you. And I'm going to say, last but not least, as tradition dictates, to Ben.
Yeah, thank you. My name is Ben Wentrock. I am the team manager for system integration at FES. And yes, we are a company situated in Saxony, in Zwickau in Germany. And we have been working for over 30 years as a system engineering partner for the engineering services with the big German OEMs, car OEMs. So we are traditionally coming from the car industry. And we took a step into the fuel cells in 2017 or 2016, so 5 years ago, roughly. We saw that the logistic market was one of the volume markets for fuel cells, which was very interesting. And so we started to get more into it, found potential partners like BMW, Intelligent Energy, because it's a very interesting field. And I think it's quite interesting time because our company is moving from a system engineering service partner now to producing products, and the H2 EPAC, where Stefan is one of the project leaders, is one of our first products. So it's very interesting.
Thank you very much, Ben. I'm asking if Stefan Fenchel can hear me now again. Stefan?
I can hear you. Thank you very much. I hope you can hear me now too.
Thank you. Yes, it's very nice to speak with you from Birmingham. Stefan, please introduce yourself. My name's Peter. I'm the moderator today.
Yes, my name is Stefan Fenchel. I'm sitting here in Leipzig in Germany. Thank you for having me online and sparing me the hassle of going to pilot strikes and other hassles. I'm very glad to join you here. Today I'm representing BMW as a customer. We are the customer because we started integrating hydrogen in our intralogistics many years ago, since 2013. And we're working also closely with FES now on expanding that idea. I mean, hydrogen in the sector of mobility is the big task. And today, I guess we're going to talk about hydrogen in intralogistics as a first sector.
Thank you, Stefan. It's a pleasure to meet you. Thank you for joining us. The weather in Birmingham is beautiful. So about 2006, I was in in Germany, Toyota made a presentation to me for a hydrogen fuel cell forklift truck. It looked like the future to me. So I'd like to know where we've gone from 2006 to today. So my question is, how did the project that we're going to describe today, how did that come about? And I throw that to the panel, and maybe one of you would like to take a lead on that. Did it come from you, Stefan, in BMW?
Well, I might say, especially in Leipzig, we were the pioneers for electromobility. We had the privilege of building the BMW i3 and the i8, which is already now history since we stopped producing it in the last few months. And in course of that, we had a few very futuristic sustainable ideas. We set up 4 wind turbines. You might see that in the background of my picture here on site. And we also had the idea by a manager Plantek, how can we improve logistics to the next level of sustainability? And he pushed it forward that we will start intralogistics fuel cell driven machinery there. And so we were the first ones in Germany to have an indoor filling station for hydrogen, which was basically breaking new ground at that time. There were no standards there. It was like just the first one. And we continue to write that story. And right now we're running the biggest hydrogen-driven intralogistics fleet in Europe. And we have even more ambitious plans in the future.
And then asking the team to my right-hand side, to get the project up and running, what was your involvement, please?
We had some starting project talks, I would say, with BMW, and we were getting into contact because there was a high trust from FES to BMW in the past. We were carrying out engineering work for BMW, I think, for more than 20 years in the car development. And so we got some interesting meeting in Leipzig where BMW said, why are you not starting to develop something for intralogistics? We have an HEV here. Can you equip this with fuel cells? And this was the starting point where it all started off. And we started then to do some concept work, and it was very, very tight because it's a tight package. Yeah, it's a very small system, and so it was challenging to find components that would fit in the box, at least in the narrow space of the HEV. And so I started to get into contact with Intelligent Energy as one of the, I would say, hard to find fuel cell suppliers with such a small air-cooled fuel cell on the market. And it developed as a very good cooperation from my point of view. So we were going very good into the project, checking for the start, for the critical points, looking at the package together and developing a strategy and a concept how to work it out for this HEV fleet for BMW in Leipzig. And I think we got to the official start of the development by the beginning of 2021 or 2020. 21. And so we had a very, very tight development schedule, very tight development plan. But as Stefan Fenchel already explained, BMW has a lot of experience in Leipzig with the hydrogen on site. And so they supported the project at any time, watching all of the steps that we did and improving the development and the concept all of the time. So
we couldn't wish for a better counterpart for this project because BMW is, as Stefan said, BMW is long doing hydrogen stuff, and they know what the challenges are about hydrogen and implementing it into intralogistics, and it was a really, really good work with them.
It's probably just worth adding, I mean, the beginnings of the project, it was very kind of practical. It was like, let's look at the vehicle, let's get a tape measure out. Can we possibly fit something in there? And what I would urge you guys to do, on our stand we have the AGV, and you can actually see the AGV. You can see the cavity where the battery used to live, which has now been replaced by a fuel cell and a hydrogen bottle and everything that goes around it. And it's all packed in there. It's very tight and quite nice, I think we all like to say. But you can see it today on our stand.
Yeah, let's say it like that. It is the first in the world with this size and in such kind of intralogistics vehicle.
Yeah, exactly.
And if I can add to that, really, since you have the vehicle not there on site right now, it's amazing because this vehicle that they're talking about has been implemented here in the BMW plant in 2003, like when we set up the plant in the first place. Back then it was a very innovative system because it was basically automated transport system state of the art, and it ran with basically every electric battery you can imagine. After a while, electric batteries fail. So we really had the idea, what can we substitute it with? And it's like a symbol for the transformation from electromobility to fuel cell electromobility, which is a hot topic currently, even in the big mobility sector. But it's beautifully described by my colleagues here.
And what's the current state of the project? How many vehicles do we have on site? So what sort of operations are they carrying out?
So
Yeah, we have.
Yeah, go on,
Yes, you
Stefan,
know,
please.
Stefan. Which Stefan? You, Stefan? And we have about 120 vehicles here on site, and we're in the progress of rolling it out. I think the first 28 are going to happen this year, and then we'll see how we're going to extend. Right now, we're in the stage of extending the production facility anyway, and the new buildings will be equipped with the autonomous fuel cell machines already.
And at the moment, we have delivered 11 vehicles to BMW. The 12th one is here at the fair at MHX. And we just need to deliver the outstanding 15 ones till the end of the year. But we made big improvements, big steps from the first delivered vehicle to this one. So we, let's say it like that, we have now the generation 2 with a new battery inside, we have new control units inside, did all the programming by ourselves and did lots of modifications to make it easier for maintenance at the BMW colleagues, just that they are afraid of putting their hands on the system, because we trained them a little bit, and so they said, yeah, it's quite easy, it's good to know, and we are not afraid of doing something by ourselves.
Is that something that you've had to invest a bit of time doing, changing the approach from the technicians and the operators on site?
Yeah, it was, as we said before, it was with each other, not they are here, we are there. It was always with each other, and we just involved BMW at all times, at all steps of the project, what we are doing, and we just had being in regular talkings with them, what can we do, what is possible for the maintenance crew, what is possible for the operators. So it was good, I guess.
Yeah, and already at the project start, the maintenance personnel was involved, so they could have an influence directly on the development, which was kind of good from my point of view. So we could design it like the end customer wants to have it, yeah, and not like showing them a finished product and then starting to discuss on what could be made better.
Yeah, to optimize.
So this was really a good start, and I think the system itself is kind of modular, which is then easy to handle for maintenance. Yeah, the components could be easily changed in very quick times to save as less downtime as possible. Let's say it like that, which is very important for intralogistics.
We've talked about where the project is today. Where are we going from here? How do we move the project forward? What's the future? What are the future plans?
I think this should be answered by Stefan Fenchel, because
Yeah.
he knows best about the plans for BMW and the plant.
Well, how much can I say? I very often in my talks I present the pictures of your system, and I say this is a perfect example for a good and fast collaboration. It's like learn fast, fail fast, get better fast. So it's really beautiful to look at. And to be honest, like I personally see, we have a production system that tries to be similar in itself. We're definitely pushing forward fuel cell intralogistics for other plants too, and we hope to set this as a new standard. And we also like the competitiveness that has come out of this. You know, like we can now compare fuel cell systems in the reliability, in the usability, in the maintenance levels, and so on. And I can just praise this project because it was fast, it was good, and it's something we can build on. That's why I said we're expanding right now the plant capacity for the battery modules production, and we will surely install the hydrogen-driven fuel cell systems in there. So there is a future, and I hope this will also lead to more projects in other plants too.
That sounds like good news. So, how about some challenges along the way then? What have we had to overcome? We've talked, I think, Harry, about some of the getting it fitted.
I would say, strangely enough, I would say the biggest challenge isn't sort of a electrochemistry fuel cell type challenge. It's the challenge we've all been facing, which is supply of parts. You know, pandemic and all of this. I mean, that's affected everybody, and we're no different. So we've been certainly been struggling with that, and we've gone through redesign cycles that were frankly completely unnecessary in order to use what is available rather than what we originally thought we were going to use. So we've had a lot of running around because of that, and I'm sure that's true across the project, and I'm sure that's across everybody in all industry. We're no different, so that's probably been one of our biggest challenges. But yeah, size, fitting the things in. I talked about the tape measure business, the measuring it up. I mean, these guys, doing it fast meant using a battery that wasn't the one you finally wanted. It was a bit bigger than you wanted. And our fuel cell is an air-breathing fuel cell. It uses air for electrochemistry and cooling. And you start putting lots of stuff in there and stopping the air, that's not great. So, having a bigger battery doesn't work ideally, so we had to work around that, and now we've got a smaller battery, that's brilliant. And, things develop and improve over time as we get the right parts in and our supply chains develop. But yeah, supply chain was a bigger challenge than we ever thought was going to be the case.
Yeah, but I think, as Harry mentioned, the biggest challenge was the tight and the rough timeline. Because as we said,
together,
the project started in March 21 and we delivered the first AGV to BMW in December 21. So it's about 9 months of developing time, getting the construction ready, getting all...
During a pandemic.
During a pandemic, getting all parts in time there, producing all the metal sheet components, producing all the wiring, doing all the programming, getting all of the testings done. That was the pretty challenge. And as Harry said, the space of the box was even a big challenge because no parts had been available, and we had to look out for other parts that could fit into the box, and doing optimizations during test runs and doing optimizations while the first vehicle was done, doing optimization in airflow management. That was, I think, one of the hugest problems or challenges that we been faced to. Let's say it like that. But at the moment, I think it is running pretty good. It is running pretty well, and we are doing further and further optimization to every vehicle we deliver to BMW. We get new knowledge, and we get new results from the plant. And as I said, it's a really good workshop with BMW and Intelligent Energy as well. And everybody that wants to have a look can come to the booth and have a look at it.
Yeah, absolutely.
Well, thanks for all the praise. I want to give some of this praise back to you, Stefan, because I really think developing that in half a year. I mean, yes, BMW can be quite pushy, but you also really performed very well. And I think this is great to show how fast can these things happen when you work together, even if the supply chains produce problem between. I think it's a success story, and I would like to build on that. To be honest, the next step we're building on right now is to work on an automated tanking refilling system, so we even have more process time saved by not having somebody refill it manually.
And were there challenges on the infrastructural side within the plant?
Well, we were building on the same infrastructure we'd had already on site since 2013 as the first filling station. We expanded that system right now. We have 4 filling stations on site, building up on the same development, improving from generation to generation. We also see on the filling, on the dispenser technology, but we're still set on 350 bars. It's still the same, basically the same technology, just minor improvements. And I think it's something very stable, something we also like to share when we have guests here. Just like, this is how we did it. You can, these materials, these dispensers are now basically available from different companies. If you want to go the path, the direction of hydrogen into logistics, the materials, the technology is there. You can now go this way.
Wanted to move on to some of the benefits that have been realized. One of the things that really I think everybody would say this catches my attention is the zero emissions at point of use, the water dripping out of the tailpipe that you can drink, shall we say. Is there so what are the environmental benefits initially that have been realized by the switch to the hydrogen fleet?
Should I answer that question?
If you would,
I would love to. And the thing is, since hydrogen in mobility is a very controversial topic even now, I would like you to look at this at energetic level, where you say what is the efficiency of the energetics of using hydrogen and then re-electrifying hydrogen in that. And there you can also look at the emission level, whereas when you say, I have an electric vehicle before, why would I use hydrogen for it to just run it electrically? But the more important task I want to point to is the process level, because when you switch from combustion engines to electromobility, you have the same problems. You need an infrastructure, you need charging stations, you need time, waiting time, process time to recharge the batteries. In that time, you need to run your logistics fleet, so you need extra vehicles, you need extra personnel, a lot of extras that once you switch from electromobility to fuel cell-driven electromobility, you don't have those problems anymore. You have filling times, refilling times of less than 2 minutes. You don't have the extra charging rooms for this heavy, you can make lead batteries or lithium-ion batteries, the same thing. You need a lot of extra infrastructure. You need a high voltage supply for those charging stations. And all these infrastructural problems, I might say, challenges, are gone when you switch to hydrogen. Yes, you have a little bit less of efficiency in terms of energy efficiency. The energetic efficiency has a bit less efficiency, but the process advantages outweigh all those that lacks by far. We can, for example, especially when you have to run a production like 24 hours or even 2 shifts, you usually have to count in a certain amount of time where you recharge the batteries. And now we have a 3-shift system. We could run these vehicles 24 hours a day, which actually many car plants have to do anyway. So the process level is the key here to look at.
I want to ask Ulf a question. For those of us unfamiliar with the refueling process, can you tell us how to recharge your hydrogen vehicles, please?
Yes, I think none of you actually, when you refill your car at the gas station, has got a special introduction of how to do it. And you basically have to imagine it's just the same. You get the nozzle, you put it on, turn the switch, and you refill it. We very often, when we have visitors here from public authorities, governments, ministers, chancellors, they all come here. We just don't even explain how to. They just try it, and you can't do anything wrong. It has to be mistake-proof, and it is mistake-proof. It is not dangerous. We very often have the reaction like, because the first image that comes to mind when people come to the hydrogen filling station, they see Zeppelin last century exploding. So that's the first picture you have to get out of people's minds. That no, this is a safe technology. There's nothing that can go wrong. The technological standard is so that even if a forklift driver would run over the whole filling station, there's nothing that could explode. There's nothing that could go wrong. And that's basically the world we're living in.
And I imagine also a leak of oxygen is not going to be lethal to the workforce.
In our newest filling station, it's actually, there's never any hydrogen within the building. Mm-hmm. So if somebody would just once the filling process has stopped, there's actually no more hydrogen even in the filling pipe. It all goes above the roof. And even if there would be the smallest leakage of hydrogen, it would just go 20 meters a second. It would go up to the roof. So that's a technological standard that cannot go anything wrong there. That leads to explosion. Sorry.
Thank you, Stefan, for that answer. So, how is the hydrogen generated in this project? Who'd like to answer that question? Is that maybe Stefan? I'll give you a break for a second, and maybe ask one of my panel here. Is there a?
Yeah, but I think the making of the hydrogen, Stefan is the best one to answer.
He's the man.
Sorry.
Generally we call it green hydrogen. We're using green hydrogen, but let's face it, there's not a lot of sources of green hydrogen currently in Central Europe. So there is a green hydrogen. Basically, the hydrogen comes from water electrolysis, and the capacities to produce green hydrogen are just now in building up phase right now. Not far from our plant here, like 30 kilometers from here, but there is about to start the biggest electrolysis in Europe. 30 megawatt, and there's a few other projects, significant projects. But yeah, that's basically the future. To be honest, currently a lot of the hydrogen is still produced from steam reforming, called gray hydrogen. But there's a number of certificates you can buy to make it green, just like as we do with the electricity and with gasoline, the same thing.
And in what format does the hydrogen arrive on site?
Yeah, currently we only have trailer supply. meaning a tube trailer with 200 kilograms of hydrogen, 250 bars. That's our current condition, comes 2 times a week. But since we're ramping up this whole thing and we have even bigger plans to use green hydrogen, we're working on a hydrogen pipeline getting into our plant by 2024. So then we have pipeline-bound hydrogen supply, and then we wouldn't even have the transport with the trailers anymore.
Okay,
maybe that's one point where I can add some more words
Please.
on that for on-site self-production of hydrogen, for example. That's what our technology is made for. We see us as a missing piece of the puzzle, as said in the beginning, and our modular and scalable systems for electrolyzers come along with in simple cabinets like server racks. We know from our IT systems, and they can be placed anywhere where we've got renewable energy available to produce on-site, on your own, with your own renewable energy if it's available. This enables the whole system to speed up very much, to place pilots very easy and quick without the need for supplying by grey hydrogen, and it also is scalable later on. So if someone wants to start with just a few vehicles, it's pretty easy to use our systems, produce hydrogen, store them, the hydrogen, compress it, and even delivering small dispenser systems is our scope. And if you later on scale up your use, your amount of vehicles, you just place some more cabinets next to the other systems, and that's all you need to do, and maybe place some more dispensing units. And it's pretty connectable to the common infrastructure Stefan just mentioned. So if you've got accessible renewable energy on site, for example, this is a good solution to just start with. And
I'm not going to use the crude term shoehorning, but by changing the characteristics of the materials handling equipment, how has it affected the performance characteristics or maybe the operational characteristics of the MHE?
I would say it's designed not to have any disadvantages, so it's more like giving you an advantage, but in general the system is powered by a lithium buffer battery. So the main power comes from the battery, and the fuel cell is then recharging the battery, and so therefore there are no performance leaks. You have all the time the uptime, and you have no voltage loss or things like that with this charging like you have it with the lead acid batteries. So it gives quite a good performance. It's all the time a high performance level, and so the machine is always ready to move fast and be on a high duty. So this is working out good. And for the operational level, I think Stefan already mentioned the best case of using hydrogen fuel cells is that you have already all the time a high availability. Yeah, for example, for free shift system, one hydrogen tank is suitable for one shift. So it means you have to recharge for free shift 3 times a day, which is 6 minutes in total, and the rest of the 24 hours the forklift or the HEV is available to move goods from A to B. Yeah, so it's available all the time, and this is the biggest advantage of using hydrogen.
Because you just save time.
Yeah.
You save a lot of time.
If I could just interject, I'll just cover a few more basic points for those of you guys that don't understand. A fuel cell generates electricity, okay? When you've got an HEV or an MHE vehicle, typically they'll use power from a battery, but they also put energy back in during regenerative braking. Fuel cell can't handle that, but the fuel cell is hybridized with a battery. So that hybridization provides somewhere for the regen braking energy to go, so that gets recaptured. Also that means, when you start up, you can kind of start up on your battery, then your fuel cell can come in, and you can manage your duty cycles. At some points you might just run on the battery, sometimes you might run on both, so you've got flexibility on how you manage your duty cycle. And obviously, well, not obviously, but you may find that the peak power is higher than the fuel cell can manage, and that might be deliberate, but the fuel cell would need to perhaps do more than your average power, and then between the two you hybridize and cover the peaks between the fuel cell and the battery. You cover the overall average power by the fuel cell itself, and between the two you get a really good combination. So some people will say the fuel cell world is the enemy of the battery world and vice versa. We actually work together, and you end up with a better solution by working together.
Yeah, and I think it's important also to mention that we are using less resources because we can use smaller batteries, like if it would be full equipped with a lithium-ion battery. We can use smaller capacities because part of the energy is stored in the hydrogen tank system. And yes, as the SOC of the battery reaches a certain level, then the fuel cell starts to recharge, like Harry just mentioned.
And the battery inside the equipment is lithium-ion?
Yeah, to give a good performance. And you can imagine it recharges several times over the day. So there's a high number of cycles, and therefore it's good to use a lithium battery so that you have a long lifetime and low maintenance, of course, which is also important.
What kind of lifting capacities are we achieving at the BMW project?
I think the vehicle is intended to have a payload of 2 tons, but Stefan, I think it's used about with 1 ton payload currently. Stefan Fenchel?
We're not seeing Stefan on screen, so okay. I wonder whether he may have...
Yeah, so the average is about 1 to 1.2 tons of payload, but in maximum it could just transport 2 tons of payload, and the vehicle itself has a weight of about 900 kilograms. So in total, in maximum, we have 3 tons that the system need to roll up, let's say it like that.
And so if we would like to adopt this technology into our warehousing operations, what advice could you give a customer? What sort of operation would this be suitable for, and what sort of considerations in infrastructure and investment should he or she be considering? Who would like to answer that question?
I think the fuel cells really come into their own where you've got quite a high level intense usage, okay? So, where you haven't got time to recharge, or if you're going to recharge where you have to have second sets of batteries or second sets of vehicles to be recharging all the time. So, if you're on it doesn't have to be 24/7, but if you're approaching that into a tense production environment or warehouse environment where you want that vehicle to be used for the vast majority of the time, that's where it really comes into its own. And the bit about charging that Stefan in Germany was explaining before, it's really important because it's like, if you're patient and well organised, you can handle charging a battery. You have to wait for it to recharge and you have to schedule that recharge. If you're not patient and you're not so well organised and you just want to be able to recharge something on the fly and don't want any delays, fuel cell is your answer, because recharge in a couple of minutes, or refuel in a couple of minutes, and off you go again. So it's really those sort of operations. And the other logistical thing about the fuel cells is it's a recharging structure that is independent of mains electrical power. Now, why is that important? Obviously, to recharge forklift trucks on traditional lead-acid batteries, you use a main supply. If you move to lithium-ion, you recharge faster, so you've got to have a bigger main supply. So you've got a whole sort of problems about, is the supply capacity there? And that very same capacity is vying with all these people with their electric vehicles, their Teslas, who also want to recharge it. So everybody's going to be fighting for that electrical capacity. Whereas, you just break that link and you just recharge and off you go. So, it's the intensive users, people perhaps with restrictions to electrical supply who are less intensive users may find it interesting as well. Ad hoc users that use a forklift occasionally, they're not the right people for this. It's more intense users.
Well, thank you very much indeed, gentlemen. That was a very interesting conversation. Perhaps a round of applause for our esteemed panellists and to our absent friend Stefan in Leipzig.
Thank you.
Thank you very much again.